Hey guys, Mrs. Dan's here. So today I'm going to be doing a video of lesson 6 because I'm going to be missing some of my students. So we will be using the commutative property and the properties of exponents to multiply and divide numbers that are in scientific notation. So if we can turn to lesson 6, which is on page 28. And take a look at the do now. You learned how to write things in scientific notation yesterday. We wish for a decimal to be there. Therefore, we write it as 2.362632 times 10 to the, and we count from the arrow to the decimal, 1, 2, 3, 4. On the other one, again, it's such a silly number to write in scientific notation. These aren't really very big or really very small. We wish the decimal to be between a 3 and a 5, so we write it as 3.512 times 10 to the, and we count from the decimal to the arrow. It's two places, but since it's a small number, the exponent's negative. And then if we were to go in reverse, this is a very small number because of the negative exponent. So when we move the decimal, we're going to move it to the left. We start from here and count 1, 2, 3. Make sure that decimal is nice and dark. And here's our answer, 0.00432. Something a little wrong with my pen today, not sure what. When this is negative, don't let it panic you, it just stays negative. We're going to move the decimal 8 places to the right. I write down all the numbers and then put my pencil where the decimal was and count 1, 2, 3, 4, 5, 6, 7, 8. That's where my decimal is now. All these gaps get filled in with a 0, and there's our number. I'm going to keep this as quick as possible. You can read through these notes on your own. I'm going to show you by example what we would do. I'm actually probably going straight to the next page, page 29. And yeah, these are the problems I want to do. You can see that this number in parentheses is in scientific notation, and this number in parentheses is in scientific notation. And when two numbers are next to each other in parentheses, it means to multiply. So I want to multiply these two numbers that are in scientific notation. It's like I want to do 3 times 10 to the 8th times 3 times 10 to the 4th. I actually don't like these multiplication signs. I'd rather it with dots. I would like to use a commutative property and just rearrange this. And then I know that 3 times 3 is 9. And I know that 10 to the 8th times 10 to the 4th, if I write a 10 out 8 times and out 4 times, I'm really multiplying that 10 12 times. So my answer is 9 times 10 to the 12th. And that is correct scientific notation. Again, sorry about my pen. if I did example 4, I can write it, I'm going to use a commutative property right away, as 7 times 5 times 10 to the 7th times 10 to the negative 5th. So 7 times 5 is 35, and that's being multiplied by 10 to the, and now I know that this is the second power. Without writing it out so many times and canceling, I kind of am getting used to these exponent rules, and I know that this would be 10 to the second power. If you need me to go to the side, 10 to the 7th is written like this. While 10 to the negative 5th, remember that's your fraction. So I have to put 10 to the 5th in the bottom. And now they can simplify. 10 over 10 is 1. And you can see I'm left with 10 times 10 in the numerator, which is a 10 squared. Now there's a problem with this answer though, because our answer is supposed to be in scientific notation. And yesterday we learned that scientific notation, you need one digit and then a decimal. With scientific notation, I needed to say 3.5 times 10 to some power. Now it can't still be to the second power. 35 times 10 to the second can't be the same as 3.5 times 10 to the second. So one way of determining it is writing out this 35 times 10 to the second as a normal number. So with the 35, I would move the decimal 2 places to the right, and I get 3,500. I need this power of 10 here to also give me 3,500. But they want me to start counting from here, because the decimal point has to be between a 3 and a 5. If I start counting from here, I count 1, 2, 3. So this exponent is to the third power. So a 35x times 10 to the second is the same thing as a 3.5 times 10 to the third. And just think about where the decimal is and how many places you have to count. So it makes this really make sense. If I start counting from after the 5, and I only have to count 2 places, my pen is giving me a hard time. If I start from here and count 2 places and only move it twice, if I start counting from a little bit behind it, of course I have to move it more times. So it makes sense that now I have to move it 3 times. If we did this practice, I want to do 6 times 2 times 10 to the 7th times 10 to the 4th. So I get a 12 times 10 to the 7th power and 4th power. That's right, 10 to the 11th power. Again, this number is not scientific notation. If I start counting from here and go 11 places to the right, and now I start counting from a little bit behind, I really have to go 12 places to the right. These two numbers are mathematically equivalent, but this is the one that's in correct scientific notation. And then letter B, 4 times 8 times 10 to the negative 7th times 10 to the 5th. 4 times 8 is 32. 10 to the negative 7th times 10 to the 5th turns out to be 10 to the negative 2nd power. Again, not correct scientific notation. I'm going to write this out as a normal number for a second. If I start counting from behind the 2, and I count 2 places to the left, I see my decimal has to end up right before the 3. So now when I write it in correct scientific notation, I now only have to count 1 time to get the decimal in that same spot. So it turns out to be 10 to the negative 1st. 3.2 times 10 to the negative 1st. And I would leave example 5 for you to do. We could even do word problems with scientific notation. And in 2010, the population in the United States will be about 3.09 times 10 to the 8th power. Spending for healthcare will be about $8,754 per person. That's important. That's how much we pay for each person. And this number here was the number of people. So when they ask about how much will the United States spend on healthcare in 2010, it means I have to do 8,754 times 3.09 times 10 to the 8th power. So I would multiply these two numbers, and you can use a calculator. So 8754 times 3.09. I forget what I'm timesing by. 3.09. $27,049.86. 2749.86. Times 10 to the 8th power. Now, this is not correct scientific notation. It doesn't say if I have to write my answer in scientific notation or not. So maybe you just want to change this to standard form. 1, 2, 3, 4, 5, 6, 7, 8. And say you're done. Or maybe you want to write it in scientific notation. And count how many places. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So either one would be acceptable. I'm going to teach you how to do division, and then we're going to be done. So these are division problems. We're going to start right with number 8. So just like with multiplication, we did the commutative property so that we could do some numbers not as powers of 10 together. And here I don't have to rewrite it because they're kind of like lined up. So that leading number gets divided together, and then these powers of 10 get divided. 6 divided by 2 is 3. 10 to the 9th divided by 10 to the 7th is 10 to the 2nd. Remember, the rule is like you can like subtract the exponents. This is already scientific notation, so I'm done. So sometimes it's that simple. If I were to do this other problem, 9 divided by 3 is 3. 10 to the 12th divided by 10 to the 5th is 10 to the 7th. Again, that's already scientific notation. So when it's in scientific notation, you're good. If it turns out to not be scientific notation, that's when we have to fix it. That's when we have to change the exponent. Sometimes we increase it, sometimes we decrease it. So when I do 4.9 divided by 7, I get 0.7 times 10 to the 3rd. Now this is a problem because this is not correct scientific notation. I can write this in standard form. I would take the decimal that's in front of the 7 and move it 3 times to get the number 700. But if I write it in scientific notation, now I have a 7. The decimal's like at the end of the 7. How many times do I have to move it from 7 to also say the number 300? You can actually go right back to the same number and start counting from here. And you can see that you only have to move it 2 times. So this is 7 times 10 to the 2nd power. The next one, 4.2 divided by 6 is 0.7. 10 to the 12th divided by 10 to the 8th is 10 to the 4th. Not correct scientific notation. I can write it in standard form to maybe help me figure out correct scientific notation. How many times do I have to move it if I start counting from here? It's only 3 times. There are word problems that also go along with this. There are about 9 billion devices, which can be written as 9 times 10 to the 9th power, connected to the internet. If a wireless router can support 300 devices, how many wireless routers are necessary to connect all 9 billion devices wirelessly? So, one router can support 300 devices. So how many routers do I need for this many devices? It's a division problem. 9 times 10 to the 9th divided by 300. Sometimes it's actually easier to write your number in scientific notation if it's not. So this 300 I can rewrite. So the top says 9 times 10 to the 9th.
Mommy, what's
quiet.
No, I need to know this.
It's written on the computer.
Okay.
Divided by, instead of writing 300, I'm going to write 3 times 10 to the 2nd power. Now this actually makes my division easier. I can divide 9 and 3. And 10 to the 9th divided by 10 to the 2nd is 10 to the 7th power. So that's how many wireless routers I need in order to connect all 9 billion devices. So how many wireless routers is this? $30 million. 30 million routers for 9 billion devices. I notice that some of these have some negative exponents, and those are probably the trickiest ones. So maybe we should go over example 11. So if I divide here, I get 4.3. That's good news. I could already see it's going to be in scientific notation. What's that sticker say? Giveaway.
Giveaway 1 exclamation point.
That's what you type in.
I did that. Give.
Are you doing capital?
No.
There's a capital G, isn't it?
Oh, continue with it.
Quiet, please. Amber. When I divide this 10 to the 12th by 10 to the negative 4th, I got to be really careful. Remember, negative exponents get rewritten as positive exponents. I could think about this should actually be like in the numerator with a positive 4. Therefore, I get 10 to the 16th power. And this is really what confuses people. We've got to get these negative exponents in this division down pat. This is what it turns out to be. And that's correct scientific notation. Let's do this next one. This is a 0.3 times 10 to the, so this negative exponent I can rewrite as a positive by moving it. I get 10 to the 18th power. This isn't correct scientific notation because of that 0.3. I wanted to say 3. In this, the 0.3 times 10 to the 18th power, think about moving that decimal 18 times to the right. Remember, I'm starting at the decimal point. So now if I start after the 3, I don't really have to move it 18 times anymore. Now all I have to do is move it 17 times because I'm one spot closer. And tomorrow in class we're going to practice this. So if you copy all of these notes, in class tomorrow you'll be able to start your homework. If you didn't get these notes down, I'll be reteaching this to you in class. Have a good night, and I will see you tomorrow.
Bye, guys.